Hello, good morning everyone. Good morning. After many days, we are meeting. I hope I'm clearly audible and visible to all of you. Yeah, good morning, Maunara. All okay? All good? Hope you are enjoying the learning at Sri Chaitanya Gosala YouTube channel. There are a lot of things which you might be learning new. Maza aa raha hoga? Yeah, I'm good. I'm good too. Good morning. Yeah. So today we are meeting after a small break, and today the topic of discussion is interesting, easy topic. But yes, you must be knowing that the most scoring chapter, the most important chapter in the NEET syllabus is basically current electricity. Yes, that is the same electric current about which you have recently talked about in your 9th, 10th classes. And now today we are going to take one step ahead in our progress in this STAR program. So while sitting back at home, we are not going to waste even a single minute, as we are aiming great results in near future. Definitely, we will be talking about some fundamentals. And yes, the pattern of the lecture is going to be the same, starting from the basic up to the best. So before completion of today's interaction, we are going to definitely discuss some NEET PYQs. Okay, so see, you have just started your preparation, and in the initial days itself, you will be definitely enjoying doing the previous year questions for the same national level target exam. Okay, yeah, chaliye, let us start, right? So the topic of our discussion today is electric current and Ohm's law. Electric current and Ohm's law. First of all, whatever your understanding is regarding the electric current, I want you to tell me. I'm looking at the chat box. I want you to tell me. Yeah, it's a lot of good morning, hi, hello, everyone, whatever happened. Yeah. But now I would want you to tell me what you understand regarding the electric current. And remember, simplicity is the best. You can just describe that in simple words. I'm not looking for any technical bookish definition. Okay. So what is electric current? Yes, Nikhil, the flow of charge in ordered motion. Okay. I won't say right or wrong right now. Let me see what story you have in your mind. Then I'm going to tell you a bit more about it. V equals to IR. Yeah, that's a basic expression related to the Ohm's law. I is equal to Q by T, rate of flow of charge. Yes, Grishma, read Madhav. Flow of electrons. Okay, nice. Rate of flow. Constant temperature, potential difference is directly proportional to current. Sushant actually tried to give a very nice attempt in order to define Ohm's law. Very nice. We'll talk about Ohm's law. As of now, let us talk about the electric current. Right. So I hope you people, I can see Q equals to NE. Navya Shri, Q equals to NE tells you about the charge accumulated on a body, whether it will be a positive charge due to deficiency of electrons, or it will be a negative charge due to some excess of electrons. So yes, you are good with the fundamentals. We are going to start with the same things. All right, let us see. So the first thing we are going to define here is electric current. Electric current. The theoretical definition, I would say, flow of charge per second. Flow of charge per second is called electric current, or you can directly say time rate of flow of charge. Time rate of flow of charge. That is, you can simply say current I can be defined as dq by dt always, dq by dt always, and that can be written as total charge by total time, total charge by total time, only if total charge by total time, only if current is uniform. Only if current is uniform. It's been many days, uniform or constant. It has been many days that we are now meeting. So I'll give you a quick recap. With me only, you have started your journey of STAR program. And yes, in the initial days, of our interaction, I have told you differentiation and integration. So in differentiation particularly, we have talked about the rate of change and a very important property that whenever a physical quantity is defined on the basis of distribution, it is always small by small. D means small change. It is always small by small. But total by total will be applicable only if the things are uniform, only if the physical quantity is uniform. For example, I'll talk about few examples. Example 1, I told you pressure. Pressure, everyone knows. What is the definition of pressure here? What is the definition of pressure? I'm just giving some examples. Tell me the definition of pressure. How do you define pressure? Do you say pressure is force per unit area, perpendicular force, that is thrust per unit area? So if you say pressure is thrust per unit area, you will be writing it as dF by dA, always valid. You'll write this as dF by dA, always valid, small by small, always valid, but that will be equal to F total by area total. Either it will give you the average value, or this formula will be applicable only if your pressure exerted is uniform. Only if your pressure exerted is uniform, or otherwise it will give you the average pressure. It will give you the average pressure. Example 2, Newton's second law. You have recently discussed the Newton's laws of motion probably. Newton's second law, it says external force is directly proportional to time rate of change of linear momentum, or mathematically you can simply say that is dP by dt, always valid. dP by dt always valid, but that will be total change in momentum. D means small change, delta means big change. So total change in momentum by total time only if external force is constant. Only if external force is constant, or you can say otherwise you want to find average value. So small by small is always valid, total by total is valid only if the things are uniform, or you want to keep it uniform by talking about average values. Another example before talking much about the current. Example 3, let us talk about the density, volumetric mass density, rho, that is dm by dv, always valid. dm by dv always valid, small mass by small volume, but total mass by total volume only if you will say the body is uniform or density is constant, or you are interested in average value, average density. So, but sir, since our childhood we are always writing density as mass by volume, what you are saying here? I am saying since your childhood, the bodies about which you have talked about were only the uniform bodies. Those were majorly those bodies in which the density doesn't vary. The density is constant or uniform throughout. I hope that's clear for us. Okay. So whatever we have known, whatever definition we have known, that is appropriate, but whatever mathematical expression we have known, we need to look carefully for it. The rule is small by small is always valid, total by total is valid only if the distribution is uniform, only if the physical quantity is constant. Hope that's all right. Tell me, is that thing clear to you? And if that is clear to you, let us talk much about the electric current. Electric current. Here we can also say I is equal to dq by dt, which means this is telling you sort of differentiation. We will see some examples very soon. Also, if I talk about the SI unit, if I talk about the SI unit of current, SI unit, then SI unit, what is the SI unit of current? You will say coulomb per second or amperes. Ampere. Okay, capital A, right? So also you have to understand the integration based thing. Also you have to understand, see, differentiation and integration are opposite processes. Differentiation and integration are opposite processes. Okay, so if you know the differentiation format, you must be knowing the integration format. That is, from here you will say dq will be equal to I dt, on integration, integration of dq, which can also be written as total q. Integration of dq can also be written as total q. That will be integration of I dt within limits t initial to t final. I hope you remember definite integration where we know where to start the integration and where we know where to end up the integration. I hope you understand this. We will start very soon with the questions, but all of the new learners who have recently joined and who are not, who have recently joined this channel, I want you to know that I have already started this journey with differentiation and integration. So the students who have missed those lectures can find some time in the second half, or definitely you can go for a binge watch session. You know, you can watch multiple videos like a movie together. Definitely you will learn a lot. And you must be joining the Telegram channel whose link is given in the description, where we share all the updates, where we share all the important stuff, and definitely your class notes also. Okay, so yeah, a happy learning. Definitely, if you haven't studied those lectures before, you should go through it. I would suggest today itself. Okay, you'll enjoy. So a basic idea is clear to you. This is the way you define electric current. This is the way differentiation is related to electric current. Changes, small change in charge by small time, small flow of charge by small time. In rough language, we can say. Appropriately, when you will be coming here, we will be discussing in too much of detail in the classrooms. But an overview of this is in front of you, that I is equal to dq by dt and q total can be written as integration of I dt within limits t initial to t final. Okay. In terms of if we want to define in terms of graphical significance, then I have already taught you that differentiation gives you slope and integration gives you area. Differentiation gives you slope, integration gives you area. So what you can say that in graph, in QT graph, charge time graph, in QT graph, we can say the current I is defined as dq by dt. So that will be slope dq by dt at time, suppose t1. If they are asking you that in a charge time graph, they are asking you I at t equals to t1, then I will say you have to find out dq by dt at t equals to t1, which means you have to find slope at t equals to t1. Similarly, if you talk about the integration part, here we will say in IT graph, because the integration of I dt and integration gives you area. So in IT graph, the Q will be integration of I dt within limits t initial to t final. So that will be basically giving you area under curve with t axis, area under curve with time axis within limits t initial to t final, within limits t initial to t final. So this is all about the introductory part of the current, that how you can define the current, how you can mathematically express the current, and how you can relate the charge flow to the current, I hope that is clear to all of us. Okay, you can see that. Please quickly take a screenshot, then I'll take you to a very nice NEET PYQ. So it seems that, okay sir, this is just the introductory part, but believe me, NEET exam is also very, very easy. The questions, maximum number of questions in NEET come from this chapter, that is current electricity. That will be your second year syllabus. But definitely the questions are going to be way too easy, very easy scoring questions come. So quickly take the screenshot. We will see few NEET PYQs. Yeah, we will see the PYQ. I hope everyone has taken the screenshot. Right. The notes will also be, as I mentioned, the notes will also be available in the Telegram group. And you can definitely share this session to many of your friends who are enjoying the vacations sitting back at home, but we can also enjoy our learning together. Okay. So that's a NEET PYQ. A flow of 10 to the power 7 electrons per second. See, 10 to the power 7 electrons per second means number of electrons per second is given to you in a conducting wire constitutes a current of. That gives a current of. So I will say here I is equal to dq by dt, and that can be written as q total by t total, assuming that current is constant. Assuming current is constant. Why you can assume current is constant, sir? Because variation of current is not given to you. Now how the charge and current variation will be given to you? Wait for a while, give me 2 minutes, I'll explain it to you, the entire involvement of differentiation and integration also. But before that, we would like to see how the NEET PYQ is coming. So whatever I am teaching you, the NEET level will be this, whatever our learning will be here in the center, the learning will be this, learning level will be this. So always remember dear, we here as a team believe that if the exam comes out as X level, our preparation should be definitely of level X plus 1. Okay. So as of now, let us say that current is treated to be constant, Q total by T total. Now this Q total will be NE. Q is equal to NE. Someone was telling in the comment section also, Q is equal to NE, and this will be T, NE by T. So here N by T is given to you separately. You just have to multiply it with electronic charge. How do you know N by T? These many electrons per second. So basically N by T value, number of electrons per unit T value time is given as 10 to the power 7. So you will say that's 10 to the power 7 and electronic charge is 1.6 into 10 to the power minus 19. Hence the answer will be, it will be 1.6 into 10 to the power base same power add minus 19 plus 7. So the final answer is 1.6 into 10 to the power minus 12 amperes. Everything you are keeping in SI unit, hence the final answer will also come in SI units, amperes. So correct option is 1.6 into 10 to the power minus 12 amperes. Absolutely correct. Everyone out of you is answering C. Definitely here. Very nice. Happy. I'm happy. Yeah. I hope that's clear. Please take a quick screenshot. Then we will see some crucial examples. Okay. I believe you would have taken the screenshot. Let me take you to some numerical examples now. So, few basic examples we will be taking from the numerical examples. Suppose, example 1, I'm saying if, say, charge is given as AT minus BT square, where A and B are constants, A and B are constants, and T is time. T is time. Determine the time, you have to determine the time at which current ceases. Current ceases. Okay, current ceases or current stops. Seize the day means completely live the day. Seize, unseizable means unstoppable. So basically it is not exactly the NEET PYQ. I would say it is inspired. So this expression AT minus BT square, there was a question on heating effect of electric current that came in NEET. So this is inspired from NEET PYQ. This is just a portion of that question. Okay. So anyways, in later stages, we will be having this expression in front of our eyes. So let's try to deal with it. Now what the question is saying, you have Q is equal to AT minus BT square and you have to find out the time at which the current stops. So I will say, first of all, what is given to you? What is given to you is Q is equal to AT minus BT square. Second of all, what you have to find is I, that is dq by dt. Now, I hope everyone out of you knows a bit of differentiation and integration. Only a small portion of that. If anyone is a new learner, it's completely fine, dear. You can invest some 2 or 2.5 hours in second half after lunch After having your meals in the afternoon, you can take some 2.5 hours. You can go through the starting videos of our STAR program. You'll definitely get the idea. So dq by dt, A will stand as it is and t's derivative with respect to t is 1, minus B will stand as it is and t square derivative with respect to t is 2t. So that is equal to A minus 2bt. You will say for current to be 0, for current to be stopped, we have A minus 2bt must be equal to 0, or A must be equal to 2bt, or you can simply say time will be equal to A by 2b. Time will be equal to A by 2b. I hope that's clear to you. Alright. So this is one of the examples where charge is given to you and electric current is required. So you make use of differentiation. But sir, differentiation and integration are opposite processes. On the other hand, if current would have been given to you and they would be asking you the charge, definitely you will make use of integration. Alright. I'll give you that example also. I hope this thing is clear to you, all of you. Yeah, that's nice. A by 2b is correct option. Okay. Example 2. Example 2. Let me take another numerical problem. What they are giving you here is, they are saying if current is given as suppose 2t minus 3t or 2t plus 3t square. Current is given as 2t plus 3t square. Then determine the charge. Determine the charge that flows in first 2 seconds. First 2 seconds. Suppose they are giving you current expression and they are asking you the charge. Then definitely you have to make use of integration. Alright. I'll show you how. See, I will say here the charge value is given as integration of dq, small charges, you will add up, you will definitely get the total charge, q total. So that will be equal to integration of I dt within limits t initial to t final. So that will be equal to integration of 2t plus 3t square dt within limits t initial is 0 and t final is 2. T initial is 0 and T final is 2. I hope we are good with this. I hope everyone is comfortable in looking this. That I am just saying that you have to integrate it. You have to integrate it. So we are integrating it like this. Now differentiation and integration both are separable over addition and subtraction. So I'll just separate the integration term. 0 to 2, 2t dt plus 0 to 2, 3t square dt. I hope everyone is understanding. 0 to 2, 2t dt plus 0 to 2, 3t square dt. Now coefficients, numerical coefficients can be taken out of the integration. So if numerical coefficient this 2 can be taken out of the integration, we will get 0 to 2 t dt plus 3 will come out and 0 to 2 t square dt. 0 to 2 t square dt. Now what you have to understand is that we will say differentiation mein, in case of differentiation we multiply the power and we reduce the power. Integration mein we raise the power, we increase the power by 1 and divide by the incremented power. So Q total will be equal to, that will be 2 integration of t dt, t's power is 1. So you have to raise the power by 1. That means t square and divide by the raised power. You have to increase the power by 1 and divide by the incremented power within limits 0 to 2 plus 3 and it should be t square dt. T square is already available. T square is available. So you have to increase the power by 1. So that's t cube and by 3. So that's the integration. Now you have to keep the limits. So how to put the limits? Wherever the variable is, put the upper limit, that is 2 square by 2, minus wherever the variable is, put the lower limit. So if you put the lower limit, that will be 0 square by 2 plus 3. Similarly, wherever the variable is, put the upper limit. So that will be 0 to 2 I will say that's 2 cube by 3 minus 0 cube by 3. That's 2 cube by 3 minus 0 cube by 3. 2 cube by 3 minus 0 cube by 3. I'll just shift this a bit on the right side so that you can easily look for everything. And don't worry, this solution looks a bit big for the students because I am explaining it in too much of detail, assuming that everyone out of you is not that good with integration, or maybe you skipped that integration. But if all of you have already studied differentiation integration from me, it will be a very obvious thing. It will be very easy for you. Okay, so that will be, you will say 2, that you can clearly see this term is 0, and hence this 2 and 2 will be cancelled and you will get 2 square. That means 4 here, plus 3 and 3 will be cancelled. 2 cube is 8 here, and hence the answer is 12 coulombs. 12 coulombs. Correct. Banu, absolutely correct. Venkat, Radha, absolutely correct, guys. The answer is 12 coulombs. I hope you got the bit of the idea that ultimately you have to do current is equal to charge upon time. But till 10th class, you have just done total charge by total time. It was easy. And you remember the NEET PYQ I have shown you, that is also based on the NEET PYQ I have shown you, that is also exactly based on the 10th class formula only. So what will be different or special in the NEET exam preparation, sir? We will just introduce the elements of small changes, which simply means technically we might involve differentiation and integration. I hope everyone is comfortable. Please take the screenshot. Please take the screenshot and let me know in the comment section, have you understood it? I hope everyone has taken this screenshot. Now, how much you have understood it? It was okay, it was nice, or it was excellent? Tell me, did you like these questions? So if you feel complex, I might lower the level of examples. But if you have understood it very well, I will say always aim for the best. You know? Slowly, our comfort level might be 40-50% right now. But even if you understand these questions by 40-50%, dear, you just have started your journey. So after understanding 40-50-60%, it's a good thing. And the people who are understanding more than 80%, you should be damn confident about your preparation and result. Very soon we are going to rock. Okay? Understood? Chaliye. I'll take few people are saying explain example 1. Rajni, I'll explain it to you. It will be for everyone in fact. I'm explaining quickly this once again. See, what happened here is charge is given as a function of time and they are commenting about current. So when charge is given and current is required, we make use of differentiation. When current is given and charge is required, we make use of integration. So here charge is given, current is required, and current is required to be stopped, cease. Current stop means find out the current, put the current to be 0. So charge is given. If you know the basic differentiation, current is dq by dt. A will stand as it is. T's derivative with respect to t is 1. T square derivative with respect to t is 2t. Now you just have kept this current to be 0 because you wanted the current to stop. So put the current to 0, you got the answer. Very simple problem. Alright. Now I think everyone is comfortable. Alright, let me take you towards some more examples, but these are graphical examples. Alright. So example 3. Graphical examples are there. So in example 3, you are having the current versus time, or let me take it charge versus time first of all. Charge versus time graph, and the graph was given to you as, so this is 10 coulombs. Charge is given in coulombs, time is given in seconds. That's 5 seconds, and then that is 10 seconds, and then that is suppose 12 seconds. So what examiner is asking you? Determine current. Determine current I at first part t is equal to 2 seconds, third part t is equal to 8 seconds, first second part is t is equal to 8 seconds, third part is t equals to 11 seconds. These are the three parts for you. You have to find the current at different instants. Find the current at different instants. Logic is very simple here. Logic is very simple. You will say current will be equal to dq by dt. That means that will be slope. dq by dt, differentiation gives you slope. Perpendicular by base. Slope is tan theta perpendicular by base. For your revision, if it's a horizontal line, slope is 0. If it is an increasing line, slope is positive. If it's a decreasing line, slope is negative. If it's a vertical line, slope is not defined. Slope is not defined. I hope the logic is clear to you. So we will be looking for these types of lines, increasing, decreasing, horizontal or vertical. Okay, that was just the logic. Now let me get back to the question. What they are saying, guys, they are saying at t equals to 2 seconds, first part, t equals to 2 seconds. So at t equals to 2 seconds, obviously it will be somewhere here. You are having this portion of line. So this portion of line is being an increasing line. Increasing line means positive slope. So I will say I at t equals to 2 seconds means slope at t equals to 2 seconds. That will be perpendicular by base. Positive of perpendicular by base. What is this perpendicular length? 10 coulomb. What is this base length? Total 5 seconds. I am talking about the complete. This 2 seconds is forming a portion of 0 to 5 seconds. I repeat, this 2 seconds is forming a portion of 0 to 5 seconds. So that will be 10 coulomb total perpendicular length. Total perpendicular length 10 coulombs by total base length 5 seconds. So the final answer is positive of 2 amperes. Positive of 2 amperes. Suppose we are talking about the second part. The second part is t equals to 8 seconds. T is equal to 8. So can I say at 8 seconds it will be this portion horizontal line. At 8 seconds it will be this portion horizontal line, and I have already told you that that will be 0 amperes. For a horizontal line, slope is 0. For a vertical line, slope is not defined. For an increasing line, slope is positive, and for a decreasing line, slope is negative. Slope means m. Slope we denote by the symbol m. Okay? Is it fine? Right? Let me talk about the third part. Now you tell me the diagrams, the slope, the content is in front of you. You tell me what will happen at t equals to 11 seconds. Give me the answer. Comment section में बताइए. Tell me in the comment section what will happen at t equals to 11 seconds. Positive, negative, plus, minus, how much? Tell me at t equals to 11 seconds what will happen. Negative. Fine. T equals to 11. It is negative. Negative by total perpendicular by total base. So I will say for this, the 11 seconds portion is on this line, on this decreasing line. The total perpendicular length is this, and the total base length is this. Total perpendicular, total base. So what is the total perpendicular? That is 10 coulombs. And what is the total base? 10 to 12. Only this base, only this triangle base. 10 to 12, that is 2 seconds. So here the answer is coming out to be minus 5 amperes. I hope that's clear. Absolutely correct. Harini, Radha, very nice. Shraddha. All right. Understood? I hope everyone is good with it. All right. Just take the screenshot so that now we can move ahead. Take the screenshot. All right. I hope you got the idea about the current, about the flow of current, about calculation of current and charge by making use of differentiation, integration, their slope and their area. So let us start with, and this was the NEET PYQ which we have already discussed. Let us start with ammeter, galvanometer and voltmeter. Ammeter, galvanometer and voltmeter. Now I am talking about first of all the ammeter. Ammeter. You know what is ammeter? Tell me in the comment section. Tell me what is ammeter. What do you understand by ammeter? Let me know what knowledge you have. Then I will definitely enlighten you more. I'll give you some more details. That measures current. Absolutely correct. What is the difference between ammeter and galvanometer? Sir, ammeter also measures current. Galvanometer also measures current. Then what is the difference between the two? Why don't we design only one device and use it? Why we are complicating it to study two devices in our syllabus? What is the difference? Yeah, absolutely correct. Measures current. Yeah. It should be connected in series. Very nice. It should be connected in series. Absolutely. Magnetic current. It's a big word. We will talk about it later on. Parallel current, series current, we will talk about it later. Less and high, Dikshita, absolutely correct. Galvanometer is generally used to measure low amount of current and ammeter is generally used to measure high amount of current. So ammeter measures current. It measures current. Whenever we talk about the current is same in series combination. So current measuring devices, current generating devices and current controlling devices all are connected in series. Similarly, in parallel combination, we know the voltage is same. So voltage generating devices, voltage measuring devices and voltage controlling devices all are to be connected in parallel. So that measures current, I will say a big amount of current. So least count, the smallest current that can be measured. The smallest current that can be measured by an ammeter is 1 milliampere or 10 to the power minus 3 amperes. It must be connected in series. Must be connected in series because just now I told you in series current is going to be same. For ideal ammeter, now this is something which I want you to remember. For ideal ammeter, and we will quickly do one NEET PYQ also based on the same. For ideal ammeter, the resistance offered by the ammeter, which is also called as internal resistance offered by the device, offered by ammeter, that is 0. For ideal ammeter, this is 0. Means when ammeter is connected in the circuit, it should measure and only measure the current. It should not give you any additional opposition. It should only measure the current. Similarly, if we talk about the galvanometer, then regarding this galvanometer, I will say it measures very small amount of current also. It measures very small amount of current. So if you want to measure very small current and if you connect an ammeter, that might give you a 0 result. But if you want to actually precisely, accurately measure the small current, then which device you will be using? Galvanometer. So measures very small amount of current. Its least count, the smallest measurement. Least count means what is the smallest measurement that can be taken by the instrument? That is 1 microamperes, or you will say up to 10 to the power minus 6 amperes also it can measure. So definitely it is also a current measuring device. So it must be connected in series to the load. And practically, I will say practically, not ideally, galvanometer's resistance is greater than that of ammeter and it is less than that of voltmeter. You remember this thing? You try to remember this very soon. In fact, in our tomorrow's interaction, we will try to see something very interesting on the basis of this property, that practically this device, galvanometer, is having a greater resistance in comparison to ammeter and a lesser resistance in comparison to voltmeter. Now, if we talk about the voltmeter, Voltmeter measures the potential difference. Voltmeter measures the potential difference, and it must be connected in parallel. It must be connected in parallel to the load, because just now I mentioned that it's the parallel property that voltage will be same. Hence, voltage measuring device, voltage generating device, and voltage controlling device all are to be connected in parallel. Then I will say ideally, for ideal voltmeter, with ideal voltmeter, your demand is that it should be connected in parallel and it should do just the function of measurement. It should not provide any additional path to the current. For that matter, you will say internal resistance. Internal resistance will be very high, tending to infinity. It will be very high. So these things I want you to understand and keep it in mind. Okay. So let me, if you have understood it, quickly take the screenshot. We will sum up this session with a NEET PYQ. All right. I hope you would have taken the screenshot. Class notes completely will also be shared. So this is the last problem for today's discussion. That's a NEET PYQ. You can see there are two circuits. These are treated to be ideal voltmeters V1 and V2 and ideal ammeters A1 and A2. The voltmeters V1 and V2 are connected in parallel to 10 ohm, and A1 and A2 ammeters are connected in series to the battery in the primary circuit. All right. Now, if you see, there will be no current allowed. There will be no current allowed here. No current allowed, because voltmeter offers infinite resistance. Similarly, here there will be no current allowed because voltmeter offers infinite resistance. Now you will say, sir, batteries are identical, load resistance 10 ohm is identical. Even if you will connect an extra 10 ohm or extra any resistor with the voltmeter, can there be any current in the voltmeter? No. The reason is ideal voltmeter, infinite resistance. There will be no current in the voltmeter arm. If there will be no current in the voltmeter arm, then you will practically say that its presence doesn't matter. Its presence doesn't matter because as it will not have any current. If a resistor is not having any current, definitely its presence will not matter to us. And if its presence doesn't matter to us, its presence doesn't matter to us, so you will say technically both circuits behave identically. If both circuits behave identically, obviously, sir, the reading of ammeter and voltmeter are also identical. So V1 is equal to V2 and I1 is equal to I2. So see, it looks as a big problem, but the logic is very cute and very simple. All right. I hope you have understood it. Quickly take the screenshot. Absolutely correct. Right. So with this here, we complete our session. In our tomorrow's interaction, we are going to discuss Ohm's law and then definitely the story of resistance. Many PYQs I have already brought for you people. Don't forget to subscribe this channel and share this with many of your friends so that tomorrow's session will be one of the most important sessions of this STAR program, in which we are going to deal a lot of NEET PYQs from the most scoring topic of physics in NEET, that is current electricity. Don't forget to join the Telegram channel because all the video updates, the class notes and everything, every assignment will be shared in that group. Okay, I hope you have enjoyed the learning. All the best. See you tomorrow. Bye-bye.
Very, very good morning, everybody. Good morning. Am I audible and visible to everyone? Good morning, good morning. Subba, good morning. Hussein, I am good. How are you, Hussein? Shravan Kumar, good morning. Manisha, Himaja, Neelaveni, Muskan, good morning. Radha, good morning. All right. So how many of you are attending the first class with me? Please say it's my first class or just mention first class in the comment. Good morning to everyone. Subbu, Guru Prasad, Malikarjun, I'm good. Malikarjun, how are you? Just write first class. Sheikh Fahad, good morning. Neelaveni. All right. I am also glad to see you all. Glad to see you all back. Lahari, all right. Some people are there. Rakesh is there and Fahamil is there. So many are there with the first class. So those who are joining today, I hope you have watched the previous lectures where we have discussed mole concept and unitary method. First class. Okay, Rohan. So most of you will be able to understand everything that we do today and it will be a very interesting class. So be ready with your notes. Be ready with your notes and just say, okay, you have listened to my music. Thank you, Vasant. Vasant says, all right. You will be able to listen to my music also live as well when you join here. All right. All right, guys. So whatever you have attended till now, it's fine. If you have not attended still, it's fine because anyways, we'll start with the unitary method once again today. So if you are all ready to start today's class, just write ready and keep your hands away from the keyboard for some time. Okay. Just write ready and keep your hands away from the keyboard. All right. So I should not see any chats in between. We'll be talking about, yes, chocolate question will also be there. Chocolate question is also there. It's a difficult chocolate question. So that's why attend all the other questions first so that you are able to solve the chocolate question as well. All right, let us start. So today we are going to talk about stoichiometric calculation. Stoichiometric calculations means nothing but using mole concept in a chemical reaction. We will see how. Using mole concept in chemical reactions. Everything that we will do today, everything that we will do today will be unitary method. Very simple. Unitary method. Those who have attended the previous classes, you already know what unitary method is. Others might be feeling little bit of new thing, but I will be able to explain everything. So all of you will be interested in studying it. Very important topic. Every year in NEET, one question will be asked. Every year. Without a doubt, every year, one question is a must, compulsory. Let us start. See, stoichiometry means nothing but doing the calculations, but you don't comment in between. Okay, don't comment in between. Neelaveni, you also don't comment in between. If anybody is commenting something which you are not liking, you ignore that. You just listen to me, look at me, keep the comments away. Look at me. Okay, very important topic we are discussing. This particular topic, as I told before, will be used in many of the chapters like chemical equilibrium, like electrochemistry, like chemical kinetics. Everywhere it is used. Very good way, I will tell you, very simple way, so that every question becomes simple for you. Okay. Stoichiometric calculation means nothing but calculation of atoms, moles in a chemical reaction. Okay. First, let us do a small exercise. All of you know how to prepare a sandwich. Okay. So I am preparing a grilled sandwich here, where I'll take to make a sandwich, we require 2 bread slices and 1 cheese slice. By that we can get a grilled sandwich. Okay, by that we can get a grilled sandwich. Now when we are actually making a grilled sandwich at home, we might face some problems. Okay, we might face some problems. Let us see what are the problems we can face. Okay, so you need to tell me the answer of the following things. I am telling that 2 breads combine with 1 cheese to give 1 sandwich. Is it clear to everyone? Is the picture clear to everyone? 2 bread, 1 cheese means 1 sandwich. Yes? Yes, Bhanu. Okay. Good. Good. Neelaveni, good. All right. Now tell me, how many sandwiches can you make by using 78 bread slices? Quickly tell. Quickly tell. Now you need to comment fast. How many sandwiches can be made by using 78 bread slices? How many sandwiches can be made? 39. 39. Most of you are saying 39. Such a simple thing. Okay. In terms of reaction, how could I say? I would have said that. Okay. 2 bread plus 1 cheese give 1 sandwich. Okay. Whenever we write a balanced chemical reaction or balanced any reaction, that means where these numbers are there, no, these numbers are called as stoichiometric coefficients. This 2, this 1, they are called as stoichiometric coefficients. So what you did just now is you used the unitary method actually. You knew the number of bread slices. Whatever we know, we keep it on left hand side. I told you before. So 2 breads produce 1 sandwich. You have done this. 2 breads produce 1 sandwich. So then you went for unitary. That 1 bread will produce, this number goes down, 1 by 2, half sandwich. Then you checked for 78 breads. That would make half of 78, which is 39 sandwiches. Very simple. All of you have answered. We know that. It's a very simple thing. All of us know. This is stoichiometric calculation. This is a basic calculation where I give you one of the thing and ask you other thing. I could have asked something like, how many grams of oxygen is required to do the combustion of 16 gram methane? How many moles of CO2 is released by heating 50 grams of CaCO3? These are all same question only. Breads, sandwiches. Now, there can be a problem sometime. Okay, this is the simple type of question where one reactant is given, one product is asked. Now there can be another type of question. All of you, please see here. You tell me, why did you not ask me, sir, bread slices to you have given, why haven't you given cheese slices? I told that there are 78 bread slices. So when I am saying that only bread slices are given, that means you need to consider that cheese slices are present in excess. You have thousands of cheese slices. How much ever you want, you can take. So actually what you will do, you will take 78 bread slices with 39 cheese slices and you will make total 39 sandwiches. So whenever data of any reactant is not given, means it is taken in excess. It is present in large quantity. Whatever you want, you can take. I am saying 78 bread slices are there. Cheese I didn't mention. So this is first type of question. Now second one. Yes. Neelaveni, whenever cheese is not given, means it is present in excess. How much ever you want, you take like that. So when one of the data is given, means other data is in excess. Now, if I give you both of them, then can you able to do? Tell me, will you be able to do? If I give you number of breads also, if I give you number of cheese also. Danesh, everything I will be telling. Okay. Yes, you can do conservation of mass. Yes. All right. Let us see. Now this is the question next. You tell me. How many sandwiches can you prepare using 22 bread slices and 4 cheese slices? 22 breads, 4 cheese. How many sandwiches can you make? How many sandwiches can you make? Yes. Yes. Very good. You can make only 4 sandwiches. This is a complication which comes in stoichiometry, that it is called as limiting reagent. So sometimes what happens is you will take the two reactant, but one reactant will finish after some time. Whenever one of the reactant will finish, reaction will stop happening. Very good. Very good. 4 is the answer. So what you did is you took 2 breads, 1 cheese, 1 sandwich is done. 1 cheese is over. 2 breads are over. You took 2 more breads. You took 1 more cheese. 2 cheeses are over. You took 2 more bread, 1 more cheese. 3 cheeses are over. You took 2 more breads, 1 cheese. After you have used 8 breads, and you have used 4 cheese, you can't make any more sandwich. That means reaction will stop in between. Yes. So here your cheese becomes a limiting reagent. Cheese becomes a limiting reagent and bread becomes a excess reagent. So these are the second type of questions we are going to do today, where I will give you data about both the things. Be very careful. Okay, data about both the things will be given. Like 4 gram hydrogen combines with 4 gram oxygen, how much water is produced? That is a limiting reagent type question. Okay, so please remember. Okay, whenever data of all the reactants is given, it is a question from limiting reagent type. We will see how to do that. Okay, right now I have given you simple examples, so you are able to tell. But when I give you example from chemistry, you might feel little bit difficulty. Okay, this complication clear to everyone? Subha Lakshmi, I am saying that when you have only 4 cheese slice beta and you have 1000 breads, 4 cheese slice, 1000 breads, how many sandwich can you prepare? Only 4 sandwich, na beta. Even if 1000 breads are there, I can't make 500 sandwiches. Because by the time 4 sandwiches are made, cheese is over. Now you can't use the breads anymore. Breads are useless. So anything which become useless after some time is excess reagent. We will see that how to find the excess, how to find the limiting. I will tell. And something which finishes is limiting reagent. Okay. Are you all ready to do the next type of complication? Ready to see the next type of complication? Ready to see the next type of complication? We will do beta, chemical example only we will do. We are doing chemistry class, I know. It's not a home science, no. It's not home science class. But only once you see it is so simple, then you will be able to do chemistry much easily. Okay. Breads are most, cheese are less. Next problem can be from the percentage purity. Percentage purity. All of you listen carefully now. Now I will take a bread loaf, but out of bread loaves, some of the breads are expired. Some of the breads are expired. Then will you be able to tell me how many sandwiches can you make? Tell me. If some of the breads are expired, will you be able to tell me how many sandwiches can you make? Yes. Okay, then tell me this one. Now this is the bread loaf that we took. This is the bread loaf that we took. Here you can see some bread slices are nice, some are not nice. See carefully and do. Carefully. Not zero, bache. See the question first. See the question. See the question first. How many sandwiches will be able to make? Question is, slowly we'll read. How many eatable sandwich, means how many sandwich which you can consume, how many good sandwiches can you make by using 40 bread slices? And if 30% of the bread slices have been expired, think carefully and tell. I will give you time. 30% of the bread slices have expired. Out of 40 bread slices, 30% are gone. You can't use them. Rest 70% you can use. Good. Good, Lakshmi Deep. Lakshmi Deepak, good. Dikshita, good. Some are saying correct, some are saying incorrect. Viber saying incorrect. Beta, see carefully. I am not asking you to do any mathematics. No chemistry, no maths. Just basic common sense. Everyday common sense. 14 is correct. 14 is correct. So what we did is, you said, sir, there are 40 bread slices, but 30% are expired. That means only 70% are usable. 70% are usable. 70% are usable. So you will say, okay, how many breads are usable? Usable breads are 70% of 40, which is 28 breads are usable. And 28 breads will make how many sandwiches? 14 sandwiches. So answer is 14 sandwiches. Is this clear to everybody? We will be able to connect. I am not telling any chemistry right now. Wait for some time. Okay. When you go to first standard, you don't ask your teacher, no ma'am, what is the spelling of banana? First she will tell you A, B, C, D. Then she will tell, join the words. Okay. So don't think yourself as very smart or don't think yourself as very dull as well. Think that you are in 10th standard, just went to 11th. Yes. Okay. Very good. Now let us take it to chemistry. These are the three types of questions we will do. Simple questions. Okay. Simple question. One thing given, other thing asked. Limiting reagent related question. Tomorrow we will do this. This will come tomorrow. Today we are doing only simple one. Tomorrow we will only discuss about limiting reagent type. And day after tomorrow we will talk about percentage purity related. When sometimes what happens is, if I say that I am breaking 100 gram of CaCO3, how much CO2 will come out? If only 50 gram CaCO3 is pure, something like that. So it is same as this one. When the whole reactant is not pure, some of it is useless, some of it is useful. Day after tomorrow. Okay. Day after tomorrow. Today we will start with the simplest one. All right. All of you now be ready with your pen and copy. How to do the question? All of you write down. Don't say anything in between. Don't do any typing. Just remember and write. How to use the mole concept in chemistry. Okay. The whatever we did just now, same concept, how do we use in chemistry? First thing is you write the balanced chemical reaction. Very first thing, write the balanced chemical reaction. Don't write anything. Okay. Lahari, don't write anything. You see, if you don't understand now, you come to me, I will give you 1000 rupees. But don't write anything right. First thing we'll do, write the balanced reaction, because once I write 2 sandwich plus 1 cheese, 2 breads plus 1 cheese give 1 sandwich. Until I write this, I will not be able to solve the question. Balanced reaction. Mention the physical states of all the reactants and products. Mention the physical states of all the reactants and products. After we do this, we will write the mole data, mass data, volume data. Mole, mass, volume, according to the stoichiometric coefficients. So after you have balanced, you would have got some numbers, stoichiometric numbers. According to those numbers, I will write moles, mass, volume. Moles, mass, volume. Moles, mass and volume of all the reactant and product I will write. Then I will use unitary method and compare any two things. I will use unitary method and compare any two things. You will be only able to understand if you don't type. Okay. Let me show you one question. All of you see here. All of you see here. Just understand the full question and then tell me whether it is clear or not. Till then, don't write anything. You just copy it. Okay. See the question. Question can be like this. Simple question I am saying. Calculate the mass of oxygen. Calculate the mass of oxygen which will react with. Write this question. Calculate the mass of oxygen. O2 we are talking about, oxygen gas. Calculate the mass of oxygen gas which will react with 2.5 moles of carbon solid to produce carbon monoxide gas. To produce carbon monoxide gas. First thing that I will do, step 1, I will write the balanced reaction. C solid plus O2 gas. I want to prepare carbon monoxide gas. Okay. Reaction is written. Now I will balance it. You balance it however you want to balance. If you want to put a half here, you can say 1 carbon, half oxygen, 1 CO. Or if you want to balance it like this, 2 carbon, 2 oxygen, like this, 2 CO. Okay. 2 moles of carbon react with 1 mole of O2 to give 2 carbon monoxide. All of you know this much of balancing. This is the balanced reaction. After balanced reaction, what we do is we write moles, mole data. Whatever the stoichiometric coefficients are there, no, that means that many moles are reacting. That means 2 mole carbon react with 1 mole oxygen to give 2 mole carbon monoxide. Just like we did for the breads and cheese. 2 bread, 1 cheese, 1 sandwich. Here 2C, 1 O2 gives 2 CO. This is mole data. Now convert these moles to mass. Convert the moles to mass. 2 mole carbon. When moles are given, mass is asked, you do 2 times molar mass. Means 2 times 12 gram carbon. 2 times 12 gram carbon. I can convert 1 mole of oxygen to, I can say 1 mole oxygen means 32 grams of oxygen. Okay. Molar mass of oxygen. 2 mole carbon monoxide means 2 times molar mass of carbon monoxide. Carbon monoxide, carbon is 12 gram, oxygen is 16 gram. So 28. Carbon monoxide ka mass 28. 2 times 28 gram carbon monoxide. So I converted mole to mass, mole to mass, mole to mass. Okay. I can convert, I don't want the answer, na beta. Wait for some time. I know you might be able to solve it. Wait for some time. Let others also understand. Mole, mass. Then we will go for volume. Volume at STP. Volume at STP. We know that only gases occupy 22.4 liter at STP. So this is a solid. I will say volume of solid, I don't know. Nobody knows. Because it is a solid. Okay, for a solid volume, we don't know. We need density for that. But for a gas, we know 1 mole means 22.4 liters. So 1 mole means 22.4 liter at STP, oxygen gas. And because this is also a gas, 2 mole means 2 times 22.4 liter at STP. Just tell me, will you all be able to write mole, mass, volume data according to the given stoichiometry? Just say yes or no. I don't want the answer, bache. Just say yes or no. Will you be able to write the mass, moles, volume data? Yes. Okay. Now we will use unitary method and compare the any two things. I could have asked you volume of CO. I could have asked you moles of CO. I could have asked you volume of O2. Anything, any two things you can compare. Once you have written this now, any two things you compare. Any two things. Whatever is given, keep it on left hand side. Whatever is given, whatever is asked, keep it on right hand side. Now I am looking at the question. Question says, bache, calculate mass of oxygen. So this is unknown. This is unknown. Mass of oxygen. I will keep it on right hand side, which is required to react with 2.5 moles of carbon. Moles of carbon. It is known. So I will keep it on left hand side. LHS, RHS. Carbon is given. Oxygen is asked. I will compare these two things. Simply I will say 2 sandwiches, 32 gram oxygen. 2 mole carbon, 32 gram oxygen. 2 mole carbon, 32 gram oxygen. 2 mole carbon react with 32 gram oxygen. Simple. So, unitary method. 1 mole carbon will react with 32 by 2 gram oxygen. So, I gave you how much mole? I gave you 2.5 mole. I gave you 2.5 mole. So, if 1 mole reacts with this much, then 2.5 mole carbon reacts with 32 by 2 into 2.5. Into 2.5. This goes 16 times. 16 into 2.5, which will be 40 grams. That is the answer. Tell me, is it very simple, or is it very, very simple, or is it the simplest? Simple, very, very simple, or the simplest? Simple, very, very simple, simplest. Now you got the answer. Good. Now you will try one. Do you want to try one? Yes. Okay. Now we'll try one. All of you do this question now. I want you to complete the question in 1 minute. Calculate the mass of hydrogen required to produce 3.6 gram of water. Just tell the answer, all of you. Try this and tell me the answer. Calculate the mass of hydrogen gas required to produce 3.6 grams of water. I am helping you to write the reaction. H2 plus O2, H2O. Always mention the physical states. If you don't mention the physical state, no, you will do a mistake in volume type of problem. Okay. All right. Balance it. Did you balance it or you did without balancing, bache? Did you balance it or not? You must balance it, no? Yes. So balance it first. H2 plus O2, H2O. 2 oxygen, I will make it 2 water. 4 hydrogen, I will make it 2 hydrogen. Balanced. Okay. Now, see, if you want, you can write all the datas, but because I am talking about mass and mass, I will just write the mole and mass data, just to be little fast in the question. 2 mole, 1 mole, 2 mole. 2 mole hydrogen, 1 mole oxygen, give 2 mole water. I will write the mass data. Hydrogen, 2 mole का मतलब 2 times 2 gram. Because H2 का molar mass is 2 gram. 1 mole of oxygen means 1 time 32 gram. And 2 mole of H2O means 2 times 18 gram. Okay. I have written all the mass data. Now, mass of hydrogen is asked. Mass of hydrogen is asked. So, I will keep mass of hydrogen on the right hand side. RHS, right hand side. Mass of H2O is given. I will keep the mass of H2O on the left hand side. Okay. 36 gram water comes from 4 gram hydrogen. So, I will say 36 gram water comes from produced by, anything you can write, produced by 4 gram hydrogen gas. So 1 gram H2O is produced by 4 by 1 gram H2O is produced by 4 by 36 gram of hydrogen, and we want to find it for 3.6 gram. So 3.6 gram H2O is produced by 4 by 36 into 3.6, which is 0.4 gram is the answer. So answer is option 2, not option 1. Many of you did mistake. Are you all clear why you did mistake? Neelaveni, you did mistake. No, now you are saying 0.4. Before you said 0.2 gram. Yes. Is it clear to everyone? Is it simple? Yes or no? Is it simple? Is it simple or not? Everybody? Nikhil Sai, you didn't balance. Yes. Always balance. Yes, this type of question will be asked, Manisha. You find out. You check the questions of NEET last to last year, 5-10 years you see. At least 2 to 3 times you will see such simple questions. Simplest. One more shall we try? One more? All of you? One more. Yes. Subhalakshmi, please watch this video once again in the evening, beta. Or understand in the next question. Taking time, Weber. You try for 2-3, no? First time when you solve a puzzle, it takes maybe 2-3-4 hours. Next time when you solve the same puzzle, it takes 20 minutes. Next time when you solve the puzzle, it takes only 5 minutes. And the next time it takes only seconds. So it's a puzzle only. Okay. Let us do next one. All of you try this. All of you try this. If you do not comment and just understand properly, if you listen to the class properly, you will do it correct. Don't look at the comments. If people are answering, you don't compare yourself with those people. You take your time. Take 10 minutes. I don't care. Right now you are learning. Once you are learning, you can take time. Not a problem. Let's do quickly. Sujit, try the question. Sujit, try this question. All of you know how CaCO3 breaks down. This much you study in class 8th. How calcium carbonate breaks down. Thank you, Fahad. How calcium carbonate breaks down. All of you know, no? What does it give you? When calcium carbonate breaks down, what does it give you? Sujit, you tell me what is the equation. Manisha, you tell what is the equation. You should know this much equation, no? Calcium carbonate, CaCO3 is a solid. On decomposition, it gives calcium oxide, solid, and CO2, gas. This is the reaction. You shouldn't say we don't know this reaction. You should know this reaction, all of you. It's a must. All of you have studied this, no? In small 8th standard, 9th standard. Yes. Now, good option, you are saying correct. Now you see, mass of CO2 they are asking. First, balance. 1 calcium, balanced. 1 carbon, balanced. 3 oxygen, 1 plus 2, 3 oxygen, balanced. 1 mole react to give 1 mole and 1 mole. Means 1 mole, 1 mole, 1 mole. Convert to mass. Mass. Calcium ka molar mass is 40 gram. You should know this. Calcium 40 gram. Carbon 12 gram. Oxygen 16 gram. Add them. 40 plus 12 plus 48. You will get 100 gram. So molar mass of CaCO3 is 100 gram. 1 mole of CaO. 40 plus 16. 56 gram. CO2 is 44 gram. Okay. Now, balance. Balance is done. Do the question. Calculate the mass of CO2. Unknown. Mass of CO2. You can see here. It is unknown. I'll keep it on right hand side. 2.6 moles of CaCO3. Moles of CaCO3 are known. I'll keep it on left hand side. 1 mole give 44 gram. 1 mole give 44 gram. 1 mole gives 44 gram. So, 2.6 mole will give how much? That is the question. Simple question. Simplest question. 1 mole calcium carbonate produce 44 gram CO2 gas. So, 2.6 mole will produce how much? Which will be 2.6 into 44 gram. Solve it. Double of 44 is 88. Now you multiply 114, you will get. Okay. 114.44 gram. That's all. Simple. Third option. Is it clear to everybody? Manisha, is it clear to you? Sujit, is it clear to you? Are the questions simple or not, Sujit? If you are still not getting, Wait for the next one. If you're still not getting, wait for the next one. Lakshmi will give. I will give the other questions as well. Let's do one more. Let's do one more. One more. Good. Neelavani, good. Manisha, good. Krishna, good. Charan, Meka, good. Okay, next one. All of you, try this. All of you know the reaction of nitrogen and hydrogen. Balance it nicely and then try. Calculate the volume of ammonia produced by reaction of 4 moles of N2 with excess of hydrogen. It's a simple type question only. N2 is given, so breads is given. They are asking sandwiches. Okay, you said first, no problem. Do the question. Breads are given, sandwiches are asked. Tell the answer quickly. Option number. Okay, good. 179.2 liter is good. Option 2. That's great. Good. Clap for yourself. 179.2. Very good. All of you write the reaction. N2H2 give NH3. Always write the physical state. Gas. Good ASR, good. Gas. 2 nitrogen. I am making it 2 nitrogen. Nitrogen balanced. Hydrogen 6 multiply by 3, 6 hydrogens. So stoichiometry become 1, 3, 2. 1 mole react with 3 mole to give 2 mole. Okay. Now, we are concerned about moles of nitrogen and volume of ammonia. So I need the volume data of ammonia. Okay. Volume data of ammonia I need. 2 mole ammonia means I'll directly write the volume data, bache. I'm writing the volume data. 2 mole means 2 times 22.4 liter ammonia. Okay. This is what we need to find out. So I will keep it on right hand side. Moles of nitrogen, I will keep it on left hand side. So I don't need anything else. I just need this on left hand side. 1 mole nitrogen produce this much. So we'll say answer 1 mole of N2 gives 44.8 liter ammonia at STP. 1 mole give this much and 4 mole give how much? 4 mole nitrogen will give 4 times 44.8. Okay, do the calculation. 179.2 liter. This is the answer. Now tell me, are you able to solve all the questions yourself or not? If you are able to solve all the questions by yourself, say, I am hero. Say, I am hero. Yourself. You are saying to yourself that you are hero. Good. If you are able to solve the question yourself, say, I am hero, like that. We'll do one more. Hansika, good. Good. You are heroine. Good. Hero, heroine, whatever you are. Very good. One more. Hasini. Do the next one. Good. I will scold you next time also. But study properly. Next one. One more. Quickly. Fourth one. Do the fourth question. Combustion reaction, all of you must know. Combustion means you are taking a hydrocarbon, burning it with oxygen to give CO2 plus H2O. H2O is always a liquid. Okay, this is the combustion of methane. This is the combustion of methane. If you don't know combustion reaction, it's okay, I've written. This is the reaction. Methane reacts with oxygen to give CO2 plus H2O. That is what combustion is. Balance the reaction. Balance the reaction. Get the answer. Quickly, all of you. Balance the reaction, get the answer. Krishna, yes, you are hero. All of you solve it. Option 4. Quickly you are getting. Very good. If you are getting so fast, that's very, very good. But if you are getting wrong, you take care. I have not balanced the reaction. If you have not balanced the reaction, you write, I am idiot. Write in the chat box, I am idiot. I mean you, not me. Write in the chat box. If you have not balanced the reaction directly, if you did, you write, I am idiot. Quickly write. Did you balance? Did you balance or not balance? If you didn't balance, then how will you get the answer? Balanced. Okay. If you have balanced, then you might get correct answer. Let us see. But most of the answers that I am seeing are incorrect. So that's why I am saying. Yes, Deepika is saying correct. Deepika is saying if we balance, we are getting third answer. Deepika, it's not an option for you to balance or not. You have to balance. Answer can only be one. Yes, good. Say I am idiot. Those who are saying answer 4, say I am idiot quickly. Those who are saying option 4, first write I am idiot, then say option 4. Arey, balance it, balance. Yes, you didn't balance. One carbon, 4 hydrogen, multiply by 2, 4 hydrogen. Oxygen, 2 plus 2, 4 oxygen, multiply by 2, 4 oxygen. Yes. So, the balancing become 1 mole, 2 mole, 1 mole, 2 mole. 1, 2, 1, 2. This is the balancing. 1, 2, 1, 2. 1, 2, 1, 2. How many molecules of water? So I'll write the molecule data of water. 2 mole means 2 Avogadro water molecules. 2 Avogadro water molecules. Produced by combustion of 224 ml of methane. I will write the volume data of methane. 1 mole methane means 22.4 liter methane at STP. So I am comparing volume data of methane which is given. So I will keep it on left hand side with the molecule data of water which we'll keep it on right hand side. Okay. All right. So 22.4 liter produce 2 Na molecules. 22.4 liter produce 2 Na water molecules. 22.4 liter of methane produce 2 Na water molecules. 224 ml they are asking. So 1 liter will produce 2 Na by 22.4 molecules of H2O. Okay. So 224 ml. 224 ml means 0.224 liter. Okay. ml I am converting to liter. 0.224 liter will give you 2 Na by 22.4 into 0.224. This will go 100 times. So 0.02 Na is the answer. Third option. Okay, questions are easy, bache. Questions are easy, but you need to balance. If you don't balance, people will call you what? Tell me, if you do not balance the reaction, what will people call us? If we don't balance, what will people call us? Good, Ravichandran. Yes, idiot. Good, Muskan. Every time you do a mistake and get the answer wrong, no, write big on the top, idiot. When you do correct, write big on the top, hero, like that. So more number of heroes if you have in your book, then you are a hero. If you have more number of idiots, you need to improve. Now I got, okay, Hansika, good. I hope it is clear to everybody. I have a chocolate question, but we couldn't reach here. If possible, you guys try this question. Okay. But I will give you the answer in the next class. All of you try this question. I will give you the answer in the next class. Or if you are able to stay here for next 5 minutes, if you are able to stay, I'll tell you the answer. I will tell you the answer. This is a chocolate question. If somebody gives me the answer correct in the first time, then you will get the chocolate. I'll wait for 2-3 minutes. You can try. I will tell. First you try. How many moles of aluminium will be required to react with amount of oxygen gas? That oxygen gas which is same as the oxygen gas which is used in combustion of 2 moles of ethane. It is a difficult question, everyone. Okay, it is a difficult question. There are 2 reactions now. Equations you want. Arey, you should think of equation yourself, bache. Now you are big enough. Ethane is C2H6. Gas. Combustion means react with O2 gas. Give CO2 gas, H2O liquid. Balance this. Balance this. Then you see for 2 mole of ethane, how much oxygen is required. First you see that. Then that same oxygen I am using with aluminium solid. It is an advanced type of question. Little bit difficult type of question. So you might not get the answer straight away. You are all just simply writing the answer. Neelaveni, Manisha, Allu, Krishna. It's a wrong answer. It's a wrong answer. Okay. So think, use brain first. Balance the first reaction. From there, if 2 ethanes are there, then how many oxygens are there? Those many oxygens, if they are here, then how many aluminiums are there? That is the question. Sujit, bye-bye. Revise the first 5 lectures and then come in the next class. 4 moles is not correct. 2.78 is not correct. Oxygen, ethane. Ethane given, find oxygen. Then same is the oxygen here. Oxygen given, find aluminium. 2 steps. Think yourself, answer is 9.33. Next class I will solve. Next class I will solve. Okay. Chalo. Say bye-bye now. Option 4 will come. Next class I will solve. Bye-bye. See you in the next class. Please revise it. Try this question. Try this question. You might be able to get the answer in 10 minutes. Not a problem. Take your time. All of you will try this now? Right? I will try. Write that I will try and say bye-bye. Okay. All right. Thank you. Thank you very much. Try this question yourself.
topic is the part 1 in sexual reproduction in flowering plants. Sexual reproduction in flowering plants. Okay, na? Our new chapter is sexual reproduction in flowering plant, nothing but angiosperms. Flowering plants, nothing but angiosperms. In the part 1, how to learn about how does pollen grains obtained from male organs for the purpose of the sexual reproduction. Almost all the parts of the flower are modified leaves. For example, sepals are there in a flower. First whorl or outermost part of the flower is a sepal. In second whorl, petals are there. Third whorl, stamens. Innermost whorl, carp. All these are modified, but functionally or purposefully, function is variable from organ to organ. But all are collectively helpful for sexual reproduction. Ultimate aim of the sexual reproduction is production of progeny through the seeds. Production of progeny through the seeds. Observe here, 4 types of floral leaves are there, or 4 types of floral organs. Such are broadly divided into 2 categories in a flower. First 2 are non-essential organs or accessory organs. Next 2 types of floral organs are essential organs. Okay, na? Okay, thank you for waiting. Sorry for the interruption. Yes. Before going to the detailed account of the production of pollen from male organs, you should learn about types of floral leaves. Sepals, petals, stamens and carpels, all are types of floral. Why these are called as the types of floral leaves? Because all these are modified leaves. Sepal is a modified leaf. Petal is also modified leaf. Stamens, carpels, everything is a modified leaf for the sake of or purpose of sexual reproduction. Purpose of sexual reproduction. Observe here. First 2 whorls are not important when compared to the importance of the stamens and carpels. That's why these are called non-essential or essential or accessory organs. Special sepal function is protection to inner other floral leaves. Petals are helpful for attracting of pollen transferring agent like insects for the sake of cross-pollination. Male organs, production of sperms or gametes. Female organs, production of eggs or female gametes. Okay, finally we can say flower is a modified shoot for the purpose of sexual reproduction. Okay. Observe here the real image. Sepal generally green color, petals are colorful, stamens male organs, carpels female organs. Now the detailed account of microsporogenesis. What is the meaning for microsporogenesis? Production of or formation of microspores. Microspores formation is the microsporogenesis. Microsporogenesis. Lag on the okay. Production of microspores. The site for the production of microspores is the anther of the stamen. In each stamen, mainly 2 parts are there. One is the filament, another part is the anther. Anther is the exact site for the development of microspores. Okay, formation of microspores inside of the anther is known as microsporogenesis. Microsporogenesis. Observe here. Anther is a broad knob-like structure and fertile part of the flower. Why it is called as the fertile pod? It is able to produce sexual organs or sexual spores like microspores. A typical angiospermic anther has two lobes. Number of lobes in each anther, 2. Observe here in this diagram, this area is the one lobe, it is the another lobe. This is the another lobe of the anther. In each lobe, number of thecas are different from species to species. Based on number of lobes, number of thecas in each lobe, anthers broadly classified into two categories. Anthers broadly classified into two categories. One is the monothecous anther. Another one is the dithecous anther. What is the major variation between monothecous and dithecous anther? If each lobe of anther consisting of only one theca, it is the one lobe. This is the second lobe. Total two lobes are there. If each and every lobe is similar to a theca, and one theca is present in entire lobe, that is meaning for monothecous. Mono, single, theca in each lobe. Whereas in dithecous condition, identify this diagram here. This is the one lobe. One lobe of anther, second lobe of the same anther, furtherly differentiable into two thecas, theca 1, theca 2. Even in second lobe also two thecas are there, theca 1, theca 2. Due to the presence of pair of thecas in each lobe, it is called dithecous anther. Dithecous are the most common in majority of the flowering plants. Monothecous are very rare condition. Most common condition is dithecous anther. Okay, I think you can get an idea about the monothecous and dithecous. If a lobe with single theca, monothecous. A lobe of anther with two thecas, pair of thecas in each lobe, dithecous. Give answer for one question. In monothecous anther, total how many thecas are there? Two thecas. In each lobe, one theca. Both the lobes together called as two thecas. Hence, monothecous anther is also called as bisporangiate anther. Bisporangiate anther. Another name of monothecous anther is bisporangiate. Why this is the monothecous is called as the bisporangiate? Another name of theca is the microsporangia. One theca is the one microsporangia, second theca is another microsporangia. Total two sporangias are there. Due to the presence of two sporangias within a anther, it is called bisporangiate. It is a rare condition. Dithecous, coming to dithecous. Other name of every theca is the microsporangia. So total how many microsporangias are found in each lobe? 2. In entire anther, 4. 1, 2, 3, 4. Total 4 microsporangias. Hence it is a tetrasporangiate anther. Tetrasporangiate anther. Based on diagrams, we can construct some kind of questions here. This is the anther is example for first option tetrasporangiate, second option dithecous, third option a lobe with two theca. All are true statements. Once again I will repeat. This is the anther is an example for question is completed. Option 1 tetrasporangiate, option 2 dithecous, option 3 bilobed, third option bilobed. All are correct. Why this anther is called as the bilobe? It has two lobes. This is the one lobe, it is the second lobe. Why that bilobed anther is also called as the dithecous? In each lobe two thecas are there. Number of thecas in each lobe 2. And why it is called as a tetrasporangiate? Total number of microsporangia in overall anther 4. Other name of the theca is the sporangium, microsporangium. Another name of theca is the microsporangium. Total number of microsporangias in entire dithecous anther 4, hence is named as tetrasporangiate anther. Tetrasporangiate anther is, or dithecous anther is very common. Bisporangiate anther or monothecous anther rare. This is the transfer section of tetrasporangiate anther. TS, transfer section. In this section, this is the one sporangium, nothing but theca. It is the another sporangium. In a lobe, even in second lobe also 2 microsporangias are there. In second lobe also 2 microsporangias. The name of this chamber is microsporangia. Another name of it is pollen sac or pollen chamber. Pollen chamber or microsporangia. How many microsporangias are found in dithecous anther? 4. How many pollen chambers are found in dithecous anther? 4. Why this microsporangia also called as the pollen chamber? Because pollen producing chamber. Pollen formation or development of pollen grains takes place inside of this anther or pollen chamber. Hence it is called as the pollen sac or pollen chamber. In structure of each microsporangium or pollen chamber, at center one fertile tissue is present. Name of this tissue is Microsporogenesis tissue. Sporogenous tissue. This is the sporogenous tissue. The sporogenous tissue encircled by multi-layered anther. Multi-layered anther wall. The outermost layer of this anther wall is epidermis. The name of this layer is epidermis. Outermost layer of the anther wall. Just inner to that anther wall, one more layer is there. It is called endothecium. Second layer from outside in anther wall is endothecium. Endothecium. Innermost layer of the anther wall. Actually, it is the biggest layer. Cells wider with dense cytoplasm. Even the number of nucleus also either 2 or more than 2 nucleus are present here. The name of this layer is the tapetum. Tapetum layer. Between the endothecium and tapetum, so many middle layers are present. So many thin-walled middle layers are there. So total how many types of layers are found in this anther wall? 4 types. One is the epidermis, outermost layer. The layer of the anther wall present just inner to the epidermis is the endothecium. Just inner to endothecium, third layer, middle layers. Innermost layer of the anther wall is the tapetum. Innermost layer of the anther wall is tapetum. Now these are 4 types of layers together called anther wall. Anther wall is the multi-layered structure that provide protection to inner sporogenous tissue. So entire anther or microsporangia possess mainly 2 structures. One is the wall. Inner to the wall, spore producing tissue is there, that is also called as sporogenous tissue. Sporogenous tissue. That wall is made up of 4 types of layers. Once again, listen. What are the name of such layers from outside to inside? Serially, outermost epidermis, next endothelium, third middle layers, and innermost layer is epidermis. Name the layer of anther wall. Name the layer of anther wall. In the number of nucleus are more than 2, binucleated or multinucleated layer of the anther wall is the tapetum. One more question here. What are the layers of anther wall helpful for dehiscence of this microsporangia to liberate pollen grains? The ultimate aim of the microsporangia is the production of pollen. The pollen produced in this anther should liberate or evolve out. For the sake of liberation of pollen grain or releasing of pollen grain, anther wall should be undergo dehiscence. Dehiscence means breakage. Dehiscence of anther wall supported by first 3 layers. The question is once again, how many layers of anther wall helpful for dehiscence of anther wall? 3 layers, such are epidermis, endothelium, middle layers. These first 3 layers helpful for anther dehiscence for the sake of releasing of pollen. Next, innermost layer provide food material or nourishment for the development of pollen grains. Pollen producing tissue is the here sporogen tissue. The ultimate aim of the sporogen tissue is production of pollen grain. But food or nutritious material required. Such nourish providing layer is tapetum. Once observe the question here. Diathecous anther is monosporangiate or bisporangiate or tetrasporangiate or dividosporangia. The right answer for this question is the tetrasporangiate. Why this diathecous anther is called as the tetrasporangiate? Tetra, 4 microsporangias. 4 sporangias are found in diathecous anther. It is the one lobe of the anther. In the same anther, one more lobe is also there. Each and every lobe is differentiable into 2 sporangias or thecas. Total 4 microsporangias are present. Hence, it is named as the tetrasporangiate. Next question. Types of layers in anther wall. 4 layers. Just you learn. Name that 4 layers of anther wall. Outermost epidermis. Second layer is the endothelium. Third layer from inner side, middle lamellas or layers. Innermost layer is the tapetum. Nutrition providing layer for the development of pollen grains. Total number of layers, types of layers, 4. Next question here. In flowering plants, a mature male gametophyte is derived from a pollen mother cell. Mature male gametophyte. I will explain what is the male gametophyte here. Whiteboard. It is a sporogenic tissue found inside of the anther wall. The tissue found inside of the anther wall is the sporogenic tissue. Number of cells are many in this tissue. Majority of the cells of the tissue are able to produce pollen. Just before the pollen formation, majority of these cells modified into pollen mother cells. Cells are modified into pollen mother cells. Short name of the pollen mother cell is the PMC. Another name of pollen mother cell is the microspore mother cell. It is actually technical name. Microspore mother cell. Short name of it is the S, MC. MI, micro, S4, MC, mother cells. Microspore mother cells are modified cells of the spoiled tissue. These cells are able to undergo meiotic cell division. Meiotic cell division. Another name of the meiotic cell division is the reductional division, short name RD. Then each pollen mother cell can yield 4 pollen grains. Initially, such grains are called as the microspores. Microspores. Pollen mother cells are in diploid condition, means 2 sets of chromosomes are there. As a result of the meiosis, it gives rise to, every one cell of the pollen mother cell gives rise to 4 haploid microspores. It is the aim of or the character of meiotic cell division. If one meiotic cell division occurs in a mother cell, that mother cell gives rise to, each mother cell gives rise to 4 haploid daughter cells. The name of each and every daughter cell is a microspore. The name of each and every daughter cell is microspore. Once again, observe here. It is actually one PMC. What is the full form of the PMC? Pollen mother cell. Pollen mother cell. As a result of meiosis or reductional division, it gives rise to 4 daughter cells. Cell 1, 2, 3, 4. Later, 4 daughter cells are separated out from each mother cell. The name of each and every this cell is the microspore. This entire development means microspore formation takes place inside of the anther. Hence, finally, we can conclude anther is the site for microsporogenesis. This topic is microsporogenesis. What is the meaning for the microsporogenesis? Formation of microspores from pollen mother cells or microspore mother cells. Formation of microspores from pollen mother cell is the microsporogenesis. How can you differentiate pollen grains from microspores? First, recently formed daughter cells of the pollen mother cell are microspores, and smaller and single wall is present around it. When it is matured, each and every microspore becomes as a pollen grain. Younger cells are microspores. Older cells are, when the microspore becomes as a older or matured, such matured microspores are called pollen grains. It is the PG. Full form of the PG is the pollen grain. Just recently modified microspores are pollen grains. What is the basic difference between pollen grain to microspore? Each pollen grain possesses a haploid single nucleus and dense protoplasm. Bilaid wall is there. Bilaid wall. Here wall is made up of only single layer in microspore, whereas in pollen grain, bilaid walls are present. It is a major variation. Structurally it is a smaller, larger, single layer, but 2 layers. Total, how many pollen grains obtained from each pollen mother cell? The single pollen mother cell can yield 4 pollen grains by the single meiotic divisions. Likewise, to yield 100 pollen grains, to yield 100 pollen grains, how many meiotic cell divisions are required? Every one meiosis gives rise to 4 pollen grain. For 100, how many? 100 by 4, 25 pollen mother cells. In that 25 pollen mother cells, 25 meiotic cell divisions. So required number of meiotic divisions 25, required number of pollen mother cells also 25 for the sake of 100 pollen grains. This entire development or pollen formation takes place inside of the anther. Hence we can say anther is the site for microsporogenesis. Now the detailed account of the pollen grain. In each pollen grain, two layered wall is there. The outermost layer is called exine. Outermost layer of anther wall is exine. Innermost layer of the anther wall is the intine. Intine. Exine is the thickest wall. When compared to the thickness of the intine, the outermost layer is the very thickest. Innermost layer is the thin. And chemically, the exine is made up of sporopollenin. Sporopollenin chemical. The chemical nature of exine is the sporopollenin. The chemical nature of intine is the pectocellulose. Means pectin plus cellulose equal to pectocellulose. Intine made up of with a small soft material, exine made up of hard material. That's why that sporopollen provide protection to pollen grain from external hard conditions. Okay, sporopollen provide protection to the pollen from external adverse conditions. Here, it is mentioned simply, exine is not affected by high temperature and strong acids like hydrogen sulfide and alkaline. No enzyme is known to degrade it. Generally, enzymes are helpful for the digestion of different plant materials. But a plant material, sporopollenin, not digested by any kind of enzymes. So, how does this the sporopollen protect the pollen from various adverse conditions? Due to the non-degradable, a fat material is there in sporopollen. Once again, tell me what are the functions or advantages of sporopollen material for the pollen grain? Protection from high temperature, protection from strong acids and alkaline medium, and from digestive enzymes. Digestive enzymes cannot degrade the pollen material. Thus, pollen grains are preserved as a fossils even at the area of volcanic eruptions. Volcanic eruptions. Yes, observe here. Because of the presence of sporopollenin material in the exine area, pollen grains of the past plants well preserved as a pollens. If the past plants means extended plants. If the plant, entire plant is extended, species extended, even though pollens are preserved as a fossils. That kind of protection or strength provided to the pollen from sporopollen material. And in this exine material, a small aperture, nothing but pore or hole is present. Small pores or holes are present on exine material. Such apertures, nothing but pores, are called germ pores. Such germ pores are essential for formation of pollen tube that allows exit of pollen tube. For example, it is the intine material of the pollen grain. That intine enclosed by thickest sporopollen material. It is a sporopollen thick wall. In the small thin areas are present in an area. Thin areas, nothing but hole. That hole permits formation of pollen tube. Through this hole only, intine exit out in the form of tube. Now this tube is called as the pollen tube. So that this germ pore facilitates the formation of pollen germination or pollen tube formation. It is the importance of germ pore. The number of germ pores in this pollen either one or more than one. All these are the different images of pollen grains. Structurally, the pollen grains are different from species to species. Some of the pollen grains are larger, some are smaller. The external texture is also variable from pollen to pollen or species to pollen in terms of the color, in terms of the structure, in terms of the size. Pollen different from species to species. Answer for these questions. In the region of the germ pore, the exon of the pollen grain is thin area. Then only that facilitates formation of pollen tube. If the germ pore is absent, pollen grain is unable to germinate, unable to produce pollen tube. Next question. The part of the pollen grain which is thick and rigid with various ornamentations is chiefly made up of sporopollenin. The sporopollen layer is the exine. Next a small topic is development of male gametophyte. Development of male gametophyte. Germinated pollen is nothing but a male gametophyte. Very simple difference is there between pollen and male gametophyte. After germination of this pollen, the same pollen is called as the male gametophyte. In normal pollen, grain, single haploid nucleus is there. After one single mitotic cell division, if there is no meiosis, only mitotic cell division, meiotic story is completed in pollen mother cells. After one mitotic cell division, two cells are formed inside of this pollen. In that one cell named is the generative cell. Other larger cell is called vegetative cell. VC for vegetative cell. Generative cell and vegetative cell are the results of the first mitotic division in pollen grain. PG, full form pollen grain. At this two-celled condition, pollen liberated from anther and reached the stigma of another flower or same flower. At the time, this intine extruded out in the form of tubular structure. Formation of pollen tube from intine is known as pollen germination. Now this is the pollen grain is termed as the male gametophyte. Pollen grains are generally single cellular structures, but whereas in male gametophyte more than one cells are present. Such cells are: one is the vegetative nucleus, another one is the generative cell. VC vegetative cell, GC generative cell. Both the cells are able to migrate into pollen tube. Both vegetative cells as well as generative cells are able to enter into pollen tube along with some amount of protoplasm. Later, this is the generative cell undergo one more mitotic cell division. As a result of the mitotic cell division, two sperms are formed. Sperms are the daughter cells of generative cell. These two sperms obtained from one mother cell. The name of that mother cell is a generative cell. Earlier the two cells are there. One is the vegetative, second one is the generative cell. In these two cells, there is no division capability for vegetative cell. The division capable potential cell is the generative cell. Simultaneously, both the cells will enter into pollen tube. After that, there is no any kind of mitotic cell division or development in vegetative cell, but generative cell able to perform one mitotic cell division to form two sperms. Another name of the sperms to male gametes. So this entire process of development is called as development of male gametophyte. Finally, we can conclude how many male gametes obtained from each pollen grain. Two male gametes. With the help of the two types of mitoid divisions. As a result of the first mitoid division in pollen grain, two daughter cells are formed, such as vegetative cell and generative cell. After pollen germination, this is a generative cell. This is a generative cell undergoes second mitotic cell division to form two male gametes. Here we will construct one question. To yield 100 male gametes, how many pollen required? 50 pollen. In each pollen, 2 mitotic. Total 100 mitotic cell divisions required to yield 100 male gametes. Other name of the male gamete is sperm. It is about the total process development of male gametophyte. Based on these concepts, we can answer for this question. What is the least number of meiotic divisions are required for the formation of 400 pollen grains? Least number of meiotic cell divisions. For formation of 4 pollen grains, 1 pollen mother cell and 1 meiotic cell division is sufficient. But as per our question, how many number of meiotic divisions are required to yield 400 pollen grains? For 1, then 100 pollen mother cells and 100 meiotic cell divisions. Then the right answer is the second option. Next. Yes. There is no any kind of division in vegetative cell. There is no any kind of division in vegetative cell. But what is the purpose of vegetative cell? Vegetative cell provide nourishment for the development of these 2 sperms. It is a non-divisor capable. There is no any kind of capability for vegetative cell, but it provides nourishment for the development of 2 sperms or male gametes from generative cell. Okay. Finally, the maximum number of cells present in this male gametophyte 3 only. What is the name of the 3 cells? So, one is the vegetative cells, remaining 2 are sperms. All are in haploid condition. It is the mechanism of development of male gametophyte. Some of the disadvantages also there for this pollen. Read here, what are the disadvantages of the pollen grains? Pollen grains of many species, especially in wind pollinated plants, cause severe allergies or bronchial diseases syndromes. It is also called as asthma. Asthma disease causing pollen grains are found in Parthenium plant. The name of this plant is the Parthenium. The common or nickname of this plant is the carrot grass. The pollen of this Parthenium plant cause the long-term bronchial diseases or asthma disease. Once give the answer for this question. Name the plant that causes for allergy causing pollen. Name the plant that causes for energy giving pollen. Parthenium. The common name of that Parthenium is the carrot grass. Now, advantages of pollen grain. In recent days, the pollen grains are useful for the preparation of some nutritious or nutrient supplements, such are taken as a tablets and syrups to improve human health or animal health. In open market, even in Ayurvedic shops also, this kind of pollen products are available in open market in the form of capsules, pills and syrups. These are highly nutritious food supplements. It is one of the greatest advantages of pollen. The pollen consumption has been claimed to enhance the performance of athletes and racehorses. It can provide large quantity of nutrition in small capsule. But one of the greatest advantages of pollen products are pollen nutrient supplements. Next, viable period. The germination capable or live period of the pollen is called as the pollen viability. That viability may differ from species to species. The pollen viable period may differ from species to species. in some kind of members like cells, rice crop, wheat crop, the live period of or capability of a pollen to germinate is just half an hour only, in 30 minutes only. After dehiscence of anther, pollen should reach to stigma within 30 minutes, otherwise the pollen will lose their ability. Within 30 minutes, the pollen should reach to stigma, otherwise the pollen grains lose their germination capability. Whereas in other members like members of the Rosaceae family, Leguminosae family and Solanaceae, that viable period is up to some several months. It clearly explains the viable period of the pollen is different from plant species to species. Viable period. But once again I will explain what is the meaning for viable period. The germination capability of the pollen or live or intact probability of the pollen is the pollen viability. Last point, by using liquid nitrogen, we can store pollen grains for long period without losing the viability. Because the liquid nitrogen provide minus 190 degrees temperature centigrade. That much of lower temperature is useful to retain the viable period for long. Such kind of preservations are called cryopreservation. Utilization of liquid nitrogen for the preservation of biological material is known as cryopreservation. Such a pollen storing areas are also called as the pollen banks. The method of the preservation of pollen in the pollen bank is called cryopreservation. What kind of chemical substances are used in this cryopreservation? Liquid nitrogen. That give rise to minus 190 degrees centigrade. Okay. Thank you, students. I will explain second part of the sexual reproduction in next class.
Hello students. Hello students. Hello everyone. How are you all? So this is my first class with you. I am interacting with you for the first time. So let me introduce myself. For the very first thing that I'll do is let me introduce myself to all of you. Myself Madhu Yadav beta, and I teach zoology. So I am going to teach you zoology today. Hello everyone. Hi, I hope you all are fine and you all are enjoying this program. Are you enjoying this program, everyone? All right. So let us start with the today's topic, that is the animal tissues. You must have seen the topic of today's class, that is animal tissues beta, and this topic belongs to a chapter structural organization in animals. Let me tell you I hope I'm audible to all of you. Yes or no? If I'm audible to all of you, I'm going to start the topic. So please give a thumbs up in the chat section so that I will start the topic. Am I audible and visible to all of you, everyone? Please reply. Yes. All right. So let us start today's topic. So that is structural organization in animals. But this is the name of the chapter. Structural organization in animals. This is the name of the chapter. Now, if you want to study this chapter, you will find this chapter in old NCERT as well as new NCERT. But the animal tissues which belongs to this chapter, the animal tissues, we are going to study animal tissues today. If you want to study animal tissues, you will find this topic in the old NCERT. So you have to follow all old NCERT to study this topic. All right, everyone. Am I clear? Am I clear? Old NCERT you have to follow, because from the new NCERT it has been deleted. But it is a part of the NEET syllabus. So it is a very important topic, and I am going to teach you animal tissues today. I will give you a briefing glimpse of the animal tissues, right? So you must have studied animals, yes or no? You must have studied animal kingdom. Now, animal kingdom you must have studied. So many phylums you have studied. You have seen diversity of animals in the animal kingdom. Yes or no, everyone? All right. So now, you know that in animals, you have studied animals into the animal kingdom. Yes or no? So you know that all animals which you have studied into the animal kingdom, all animals are multicellular. All the animals are multicellular. Multicellular means many cells are there, right? Many cells are there. Like in Porifera, many cells are there. Porifera, Coelenterata, right? So you have studied so many phylums. Right, starting from Porifera till Chordata, you have studied 11 phylums. All the animals are multicellular. This is something without any exception is present in all the animals, right? Unicellular are not included in the animal kingdom beta. Unicellular creatures are there in the Protista, and we study Protista in the plant kingdom. We do not study Protista, unicellular things here in the animal kingdom. So all the animals are multicellular. All the metazoans, animal kingdom, metazoa, multicellular, right? So whenever there will be many cells, then only there is a possibility of formation of group of cells. Whenever there are many cells, then only group of cells can be formed, and that group of cells will be called as tissue. So we are going to discuss tissues. So first of all, group of cells will be tissues. Now can anybody tell me in which phylum you have seen for the first time tissues? In which phylum of animal kingdom you have seen tissues for the first time? Yes, tell me everyone in the comment section. Tell me in the chat section. In which phylum of animal kingdom you have seen tissues for the first time? Yes, Coelenterata phylum. Yes, very good. Some of you are giving the correct answer. Coelenterata phylum. Beta C. You have seen the level of organization. Cells are there, right? Cellular level of organization is there in Porifera. Then in the next phylum Coelenterata, there will be tissue level of organization. So cells will make tissues, then tissues will make organs, and organs will make organ system. Organs will make what? Organ system. So you have seen in the very first phylum cellular level of organization. Then you have seen tissue level of organization in the Coelenterata and Ctenophora. Yes or no? In the two phylums you have seen the tissue level of organization. Then in the Platyhelminthes organ level came, and then after that in all the phylums there is organ system level of organization, right? So now you know this. This is the structural organization in animals. That is why the chapter name is structural organization in animals. What is the organization? How the whole body of the animal is formed. So the basic unit is cell. Cells will make the group, that is known as tissues. Then all the tissues will combine and they will make the organ. So in every organ of your body, all the types of tissues are present. That's what we are going to study today. Types of tissues, right? So cells will make the tissue, tissues will make the organs, and organs will make the organ system. All right. So this is the level, these are the levels of organization. So now let us start defining a tissue. Let me define the tissue now. Right. Tissue means group of cells. These are the cells, beta. These are the cells. They are very happy to see you. Very happy to see you. They are welcoming you all in the session. In today's session, they are very happy. Why they are very happy? Because they have come close together and they are making the group. And this group of cells is known as tissues. But now, how they are connected, how they are making the group. In between these cells, there is a space. Can you see the space in between these cells? And this space, in this space, there is something, some substance is present. We can call this substance intercellular substance. Intercellular substance. Intercellular substance, or we can call it extracellular matrix. Extracellular matrix, beta. So now let us see the meaning. Inter means in between. In between the cells. It is not intra. Don't get confused with intra. Intra means within the cell. Intracellular means within the cell. Within the cell. If something is there inside the cell, it will be intracellular. So just remember the difference between intra and inter. Inter means in between, just like you must have heard of interstate competition or inter-school competition, means between different schools or between different states. But when some competition is there in your own school, among the students of your own school, that will be intra-school competition. Similarly, if something is there inside the cell, it will be intracellular. But if something is there in between the cell, intercellular. Intercellular means in between the cells. In between the cells. Extracellular means outside the cells. Outside the cells. So beta, whatever is present in between the cells, that is also present outside the cells. Yes or no, everyone? Have you all understood the meaning of intra, inter and extra? Have you all understood the meaning of inter, intra and extra? Please tell me in the comment section with a thumbs up. Yes or no? Alright, I hope you have understood now. So this group, now we can call this whole group of cells as a tissue. Now we can call this whole group of cells as a tissue. Now this is a tissue, beta. This is a tissue. So how we can define tissue? You can see that these all cells are looking similar. Yes. So this is a group of similar cells. This is a group of similar cells along with intercellular substance or extracellular matrix. That's how we can define the tissue. So let us define the tissue. Tissue is group of similar cells. Similar cells. Group of similar cells along with intercellular substance or extracellular matrix performing a specific function. They will perform a specific function. Performing a specific function. Performing a specific function. So I hope you have understood what is the tissue and in which phylum you have seen tissue for the first time. Tissues, animal tissues in the animals. First time we have seen them into the coelentrates. Coelentrates. First time in the coelentrata, right? So tissue is a group of similar cells. All are similar in structure. All are similar in origin also. Now I will explain you what is the meaning of origin, right? First of all, we are going to understand what is the meaning of origin. Yes, beta. Yes, they are similar in function also. They are similar in structure also, and they are similar in origin also. In three things they are similar. They are similar in structure, just like they are. You can see them. They are looking similar. Then they are. All are smiling, all are similar, all are smiling, right? So all are similar structurally, all are similar functionally, and origin of each cell is similar. So now what is the meaning of origin? See, let me move to the next page and let me tell you what is the meaning of origin, beta. Origin. So this story starts with an egg and sperm, right? A female gamete is ovum, egg, and the male gamete is sperm, right? Sperm and ovum. Sperm is the male gamete. It's the male gamete. We can write male like this. And ovum is the female gamete, beta. Ovum is the female gamete, right? So now when a ovum and sperm fuses, when they fuse, they will form a zygote. Zygote is a single-celled structure. Sperm is a haploid structure. Ovum is a haploid structure. Zygote is a diploid structure. But it is a single-celled structure, right? This is the starting of life, beta. Starting of life, right? A living organism, how it forms. A living organism, how it forms by the fusion of gametes, sperm and ovum, zygote will be formed. So now this zygote will divide. And it will increase the number of cells. This is a single cell and then it will increase the number of cells. So then it will become 2-celled, then it will become 4-celled, 4 cells will be there, then 8 cells will be there, right? Then 16 cells will be there, then 32 cells will be there. All these are embryonic stages, right? 32 cell stage embryo is known as blastula. And after this stage, blastula, there is formation of germ layers. Formation of what? Formation of germ layers. What are these germ layers, beta? What are these germ layers? Germ layers are those layers which will give rise to each and everything in the body, right? Every organ, every tissue, every cell is formed by germ layers. So how many germ layers are there in the embryo? How many germ layers are there? There are 3 layers. There are 3 layers. One is ectoderm, one is mesoderm, and one is endoderm, beta. If you have studied animal kingdom a little bit, you know that in some of the animals only 2 layers are present. In some of the animals only 2 layers are present. They are diploblastic animals, ectoderm and endoderm. Mesoderm is not there in them. Yes or no? Diploblastic. Then in most of the animals, all the 3 germ layers are present. Ectoderm, mesoderm, endoderm. All the 3 germ layers are present. In us also, all the 3 germ layers are present. But can you tell me, do we have these germ layers now in our body? Yes, everyone, tell me in the chat section. Do we have these 3 germ layers now in our body? Tell me. Quickly tell me. No. Yes, absolutely correct. No, beta. We don't have these germ layers because these germ layers were there when we were in embryo. When we were in embryo, these are embryonic stages, beta. Now we are an adult, right? So these are embryonic stages. In the embryo, there will be 3 germ layers, and these germ layers will be formed first, and then they will give rise to all the cells, tissues, organs of your body. And organs will make the organ system, right? All right. So this much, I think you all are understanding this much. So now you understood about the origin. Now if I will tell that the epithelial tissue origin is ectodermal or mesodermal or endodermal, you will understand ectoderm, mesoderm, endoderm. So now you understood by the origin. You understood by the origin. Whenever we are talking about the origin, we are talking about ectoderm, we are talking about mesoderm, and we are talking about endoderm. So we have 4 types of tissues, beta. We have 4 types of tissues. What are the 4 types of tissues we have? 4 types of tissues. 4 types. Animal tissues are of 4 types. Animal tissues are of 4 types, right? What are these 4 types? These 4 types are epithelial tissue, then there is connective tissue, then there is muscular tissue, beta, and then there is neural tissue or nervous tissue. Alright. So now epithelial tissue, connective tissue, muscular tissue and nervous tissue. How many types of tissues are there in us, in our body, in all the animals in which tissues are there? 4 types of tissues are there, right? Epithelial tissue, connective tissue, muscular tissue and nervous tissue. Now, the origin of these tissues, if somebody will ask you that the neural tissue is formed by which germ layer? So, the origin is beta ectoderm. The origin of muscular tissue, mesoderm. The origin of connective tissue, mesoderm. But the origin of epithelial tissue is ectoderm also, is mesoderm also, is endoderm also. In different parts of your body where epithelial tissue is present, it can be formed by either ectoderm or endoderm or mesoderm. It can be formed by any of these 3 germ layers. Are you understanding? So this is very important to understand the origin. So now if somebody will ask you the origin, you can simply tell that connective tissue and muscular tissue both are mesodermally derived. They are formed from the mesoderm. Like connective tissue. In the connective tissue, we will be studying about bone. We will be studying about cartilage. All these are mesodermal. In the muscular tissue, we will be talking about muscles. All these are mesodermal in origin. In neural tissue, we will be talking about brain, spinal cord, nerves, neurons. All these things are originated from the ectoderm. Because tissues only are forming the organs, na beta? Tissues only are making the organs. So in every organ, you will find each type of tissue in every organ. Right? Now, I will start from the epithelial tissue. So these 4 types of animal tissues are divided on the basis of origin and beta function. If you see the function, this is about the origin, and here I am going to write the function. On the basis of function, every tissue has different function. Epithelial tissue has different function, connective tissue has different, muscular tissue has different, and neural tissue has different. So epithelial tissue function is covering and protection. It will cover the body surface. Whole body is covered by skin. So if somebody will ask you, skin is which tissue? Skin is epithelial tissue, right? Skin is epithelial tissue. Now, if somebody will ask you, your buccal cavity is lined by which tissue? Epithelial tissue. Wherever there is a covering, whether it is on the outer side or whether it is on the inner surface of the body. Inside the body, we have so many organs. Every organ is covered from outside as well as from inside. Inside, there will be a space which is lined by a covering, right? So, that covering is formed by epithelial tissue, right? Protection, it gives us protection. Yes, our skin. Through our skin, it is a barrier. No pathogen can enter through our skin. It is a barrier. Yes, so it gives you protection. It is covering, protection. Now, connective tissue, it will connect various tissues and organs. It connects various cells, tissues, organs, everything. Right? In your body, wherever there is the connection, that connection is due to the connective tissue. Muscular tissue. When we talk about muscular tissue, obviously muscular tissue is forming your muscles, beta. And when your muscles are there, without the muscles you cannot move. You cannot move your hand, you cannot move your head, right? You cannot move your body, you cannot change your place. Locomotion, right? Whenever there is a change of place, that is known as locomotion. So muscles, movement and locomotion. Movement and locomotion is done by muscular tissue, beta. And neural tissue, without which you cannot do anything, you cannot control anything. Your control over the body, responses, control and coordination. Whenever somebody is asking you something, you are responding, right? How you are responding? Because you are processing that into your mind. You have a brain, you have a spinal cord, you have a central nervous system, you have a peripheral nervous system, and we are responding because of the central nervous system and peripheral nervous system. Because of our nervous system, we are responding, we are sensing, we are taking the stimulus, we are giving the response. So in all these activities, what is involved? Neural tissue is involved. So neural tissue function will be control and coordination. Control and coordination. Beta, this is the tissue which has the greatest control over your body's responsiveness. How you respond, that is controlled by nervous tissue. And one more important thing. Yes, beta. Yes, nervous tissue is important. Every tissue is important, beta. Every tissue is important in the body. Now, if somebody will ask you a question, which tissue is most abundant in your body? Which tissue is most abundant in your body? Then the answer will be connective tissue. Connective tissue is the most abundant tissue. Connective tissue is the most abundant tissue of your body. Most abundant and widely distributed tissue. Everywhere connective tissue is there to connect the cells, to connect the tissues, to connect the organs, right? Everywhere connective tissue is there. So connective tissue is the most abundant and widely distributed tissue in your body. So now you have understood what is a tissue, what are the types of tissue, what are the origin of different types of tissue, and what are the function of different types of tissue. Now I will be briefing you about the epithelial tissue. If you have understood this much, please give a thumbs up. If you have understood this much, please give a thumbs up. If you are understanding whatever I am explaining, please give a thumbs up. Alright, now let us move to the epithelial tissue. I will be explaining you epithelial tissue today. Epithelial tissue. Beta, see the name of the tissue. Sometimes, sometimes the meaning of things is in there, in the name only, right? In the name only, the meaning is there. The meaning is hidden in the name itself. Epi means upon. Epi means what? Epi means upon. Epi means upon. And thelial. This epithelial tissue can also be called as epithelium. Epithelium can also be called as epithelium. So thelium means to grow. Thelium means To grow, beta. So upon epithelium means to grow. Why its name is epithelium or epithelial tissue? Because very important, because it grows upon another tissue. It grows upon another tissue, beta. Epithelial tissue grows upon another tissue. Grows upon another tissue. And that another tissue, can anybody tell what is that another tissue? It is among the 4 tissues only. So epithelial tissue is growing upon another tissue. What is that another tissue? That another tissue is connective tissue, because connective tissue is the most abundant tissue, right? It is present everywhere. So epithelial tissue grows upon connective tissue. Wherever in your body you will find epithelial tissue, below that epithelial tissue you will find which tissue? Connective tissue, right? Next thing about the epithelial tissue. Let me define epithelial tissue. Here, this is the group of cells. Group of cells. Group of obviously similar cells. I will write group of similar cells because that is what the tissue is. Group of similar cells with little means very less intercellular substance or extracellular matrix. Intercellular substance or extracellular matrix. Group of similar cells with little means very less space is there, very less intercellular substance is there. That means the cells are compactly packed. These cells are beta compactly packed. Compactly packed cells are there, right? Now this epithelial tissue can be of 2 types. There can be 2 types, beta. These cells can be arranged in single layer. There can be single layer of cells. There can be more than 1 layer of cells. More than one layer of cells. So if there is single layer of cells, if cells are arranged in a single layer like this, single layer of cells, then this type of epithelium is known as beta simple epithelium. Whereas if more than 1 layer of cells are there like this, then it is not a simple epithelium, it is a compound epithelium, beta. It is a compound epithelium, complex, compound, not very simple. Simple means simple, 1 layer, only 1 layer of cells. They are very simple. They don't need many layer of cells. They are very simple, right? So if you need few things, right, then you are very simple. But if you need a luxurious life, you need so many things. Yes, everybody needs so many things in their life. I hope you also want so many things in your life. So that means you are also compound, right? You are not simple. Every one of us are not simple. Some people are simple, some are compound. Just like that, epithelium which is simple has only 1 layer of cells, single layer of cells. The epithelium which is compound has many layer of cells, compound epithelium. If you are understanding whatever I am teaching, please like the session. Hit the like button if you are understanding each and everything. Those who have not liked it till now, right now, do it quickly. Give a thumbs up if you are understanding the lecture. Give a thumbs up, like the session, everyone. Alright. So now, simple epithelium, compound epithelium. Now beta, there are many types of simple also and compound also. How? On the basis of structure or shape of the cell. This cell, the group of similar cells, the shape of these cells can be anything, right? It can be squamous, it can be cuboidal, it can be columnar. Mainly 3 shape of cells we will see. So let me write here types of simple epithelium. These are the two types of epithelium. Then there are types of simple epithelium. Then there are types of simple epithelium. There are types of simple epithelium on the basis of shape of cells. There can be squamous. There can be simple squamous epithelium. We will write it simple squamous epithelium. Simple squamous epithelium. So simple squamous epithelium beta will look like just the tiles in the floor. Just look at the tiles in the floor. The tiles in the floor are very, very flat, very, very thin. Yes or no, everyone? They are not very thick. The tiles in the floor are very, very thin. So it is a thin epithelium. Simple squamous epithelium is just looking like the tiles in the floor, like this. These are the cells, beta. These are the cells. And this is their nucleus. This is their nucleus. Simple epithelium. Whereas simple squamous epithelium, this is flat cells, thin flat cells, flat thin cells, right? They have irregular boundaries. And then there is simple cuboidal epithelium, simple cuboidal epithelium. So cuboidal epithelium is not flat. It has some surface. It has some surface area. It has some volume, right? Like this, cube-like. These are cube-like cells, beta. These are cube-like cells or cubical cells. Cubical cells are there. And then if it is simple columnar, then the cells will be columnar. Cells will be columnar, like this, cylindrical, like this. Can you see these cells now? Can you see these cells now? These are cylinder-like. They are columnar, they are tall, they are elongated. Yes or no, everyone? They are tall, elongated. So main three shapes of cells will be there, and on the basis of that we will tell the name of the simple epithelium. If it is simple squamous, then it looks like this. If it is simple cuboidal, it looks like this. If it is simple columnar, it looks like this. Now, it is not as simple as it looks like, right? It is not as simple as it looks like. What I'm trying to say is they have some modifications on their surface. So let me tell you those modifications. Let me tell you a very, very important property. Very, very important property. This is very important, beta. This is a very important property of the epithelial tissue, that epithelial tissue grows upon a basement membrane. Now you will tell them, you have told epithelial tissue grows upon another tissue, connective tissue. Yes, connective tissue is there. Basement membrane is the part of epithelial tissue only, and below that connective tissue is present. I will tell you everything with the help of the diagram. Epithelial tissue grows upon a basement membrane, beta, and this basement membrane is a delicate non-cellular membrane. It is a delicate non-cellular membrane. Epithelial tissue always grows on this basement membrane. Let me show you epithelial cells here. This is the epithelial cell, beta. This is the epithelial cell. Everyone look here. These are the epithelial cells, right? These are the epithelial cells. This is an epithelial cell. This is an epithelial cell. And this is the apical part of the epithelial cell. This is the apical surface, apical part. You can say apical surface, right? And this is the basal surface. This is the basal surface. Now you will see this basal surface is in contact with this basal surface, because here basement membrane is there. Above the basement membrane, epithelial tissue is there. See, everywhere you will see in buildings, below the ground floor you will see the basement. Yes or no? Below the ground floor there will be a basement. mainly it is meant for the parking or it is meant for the storage. Yes or no, everyone? So you know what is the meaning of a basement. So below this actual thing, below this epithelial tissue, there will be a basement membrane. So let me make a basement membrane here. This is a basement membrane. This is a basement membrane. And in this basement membrane, there are two layers. One is this thin layer and one is this thick layer. Right? This thin layer, this is the thin layer. This is the thin layer and this is the thick layer, in which I have made some fibers, beta. Right? So what are the names of these layers? The outer one, you can see this is the outer one. This is known as basal lamina. This is known as what? Basal lamina. And what is this? The inner one, it is known as reticular lamina. It is known as reticular lamina, and these both are making this basement membrane. So basement membrane is a delicate non-cellular membrane in which there are two layers. One is the basal lamina and one is the reticular lamina. The basal lamina is on the outer side, it is thin, whereas the reticular lamina is on the inner side and it is thick. As compared to basal lamina, it is thick. Now here you will get to see the connective tissue. Here, this is the connective tissue. This is the connective tissue, beta. This is the connective tissue. So now you understood. Now you understood how everything is there. How basement membrane is there below the epithelial tissue, and epithelial tissue cannot grow without basement membrane. It will have the basement membrane. Basement membrane is a part of epithelial tissue. Epithelial tissue will never be present without the basement membrane. Right? So this whole is epithelial tissue now, and this epithelial tissue is growing upon the connective tissue. Now you can see here connective tissue. Yes or no? Connective tissue. So now this apical surface, we will look at the apical surface. It looks simple. I have made simple epithelium only here. Yes or no, everyone? I have made simple epithelium, and in this simple epithelium you can see only single layer of cells. Yes or no? Now this apical surface can show modifications. It can show some modifications. It can show some modifications. It can show some modifications like the first modification is this, beta. The first modification is this. Can you see the brush like appearance of the cell? Let us suppose this is a cell. This is a cell, beta. Now you can see the surface area is less, only this much. But if the plasma membrane of this cell will fold like this, it will make the finger-like projections like this. So you can see how much the surface area has increased. Yes or no, everyone? The surface area has increased so much. This structure is known as microvilli. What is this structure? This structure is known as microvilli. So the apical surface of the epithelial cells, it can show some modifications like microvilli. Microvilli is what? Microvilli is finger-like projection. Finger-like projection. What is the use of microvilli? The use is, it is increasing the surface area. It increases the surface area, beta. It increases the surface area. So whenever there is more need of absorption, then it will increase the surface area. Right? Where is absorption occurring in your body? Tell me. Absorption is occurring in your body in the intestine, beta. Yes or no? You are eating the food in the digestive tract, it is going, then it is digested and then it is absorbed. So it is increasing the surface area. So microvilli. One more structure I will tell you, that is, it looks like this. If it is a cell, from this cell you will see some hair-like structures. are arising. What are these hair-like structures? These hair-like structures are cilia. Cilia. Right? Cilia. Cilia are hair-like structure. Hair-like structure. What is the use of these hair-like structures, cilia? The use is they are motile. They move. They move like this. They move in a specific direction. Right? So they move in a specific direction for the movement of substances. So this cilia allows movement of substances. Movement of substances. The cilia allows movement of substances in a specific direction. So wherever in your body movement is required, for example in your respiratory tract, beta, mucus is moving, right? So that is moved due to the presence of cilia. Ciliated epithelium is present. Then you can find cilia in the female reproductive tract fallopian tube, because ovum, I have told you, ovum is a non-motile gamete. Ovum moves with the help of the cilia in the fallopian tube. That's how it reaches to the site of fertilization. So cilia is present in the fallopian tube, cilia is present in the respiratory tract, microvilli is present in the gastrointestinal tract, in the intestine. Microvilli is also present in the nephron. Which part of nephron? Proximal convoluted tubule. I will teach you the locations, right, in the further classes. So now you have seen apical surface can show microvilli, can show cilia. Now this microvilli and cilia can be present on the cuboidal or columnar cells. I have told you already the squamous cells, cuboidal cells and columnar cells. Squamous cells cannot have these modifications because they are already very thin. So cuboidal and columnar cells will have these modifications. So now the types of simple epithelium will increase. Yes or no? The cuboidal epithelium now can be the brush bordered cuboidal epithelium, right? The simple cuboidal epithelium, I have told you, the simple cuboidal epithelium can be now smooth, or smooth means without any modification. It can be brush bordered. Brush bordered means presence of microvilli or cilia. Presence of microvilli. Presence of microvilli. Right? Here no modification. Smooth means no modification. So these terms you need to understand. And if it is ciliated, that means presence of cilia. Similarly, the simple columnar epithelium can also be like that. Simple columnar epithelium also can be smooth without any modification, can be brush bordered, it has microvilli, it can be ciliated, that means it has cilia. So these are the main types of simple epithelium, right? I have told you that there are two types of epithelial tissue, simple and compound. Then I have told you the types of simple, beta, single layer of cells. Simple. This single layer of cells can be of flat thin cells, can be of cube-like cells, can be of columnar cells, right? These cuboidal or columnar cells can be of two types. They can have microvilli, they can have cilia. Columnar cells also, they can have microvilli, they can have cilia. Are you understanding the types, right? So you have understood the basics of epithelial tissue. You have understood the basics of epithelial tissue. Now let me conclude today's class and let me tell you what I have taught you today. I have told you what is the tissue. Then I have told you the types of animal tissues, 4 types of animal tissues. Then I have told you that I have described you in brief epithelial tissue. Epithelial tissue is a tissue which grows upon another tissue, that is connective tissue. Epithelial tissue is the tissue which grows upon a basement membrane. So basement membrane comes in between the epithelial cells and connective tissue. Here you can see epithelial cells and connective tissue. In between there is a basement membrane, right? So then you have understood that these cells can show some modification like microvilli and cilia, and that's how we will name them. That's how the epithelium will be named, on the basis of presence of microvilli or cilia. So now you understood the three main types of simple epithelium and the further types of cuboidal and columnar epithelium on the basis of presence of microvilli and cilia. So now you can go through this further. You can read it from your notes, from your book, right, where this animal tissues chapter you will find, and there you can see the locations of these tissues. It is very interesting to know the locations of all these tissues in your body, right? So we will get back to this again. So stay tuned to understand more about the animal tissues. We will continue this in the next class. Stay tuned. If you have not liked this session, please like the session and just subscribe the channel, right? So that you will be updated with the more information, right? Thank you. Thank you everyone. Bye bye. Take care. God bless you all.